Okay, we're going to learn today how to use the ohm meter scale on your meter. This one is combined. It's actually a scale on the spirometer that actually will measure ohms of resistance, electrical continuity. It can test diodes or a capacitor. Now, I don't happen to have any diodes or capacitors with me, but the hookup is pretty much the same with any of these functions. We're basically looking to make sure that we either have a predetermined measurement in ohms of resistance, which is typically found in a workshop manual for some of the things you might be testing. Or in this case, I'm just going to check the continuity through a coil of wire that I keep on board in case I need to do any emergency wiring. So I'm going to test the continuity through this coil of wire to make sure that there's no break. Now, one of the things that you need to be a little bit concerned with on the ohm scale or any of these scales that I've just mentioned is that the battery in your meter is in good shape. And typically the meters will have either a little battery state of charge indicator on it. But another way to check it on the ohm scale, you can see right now the meter reading is OL, which means overload in this example. In other words, it's measuring resistance that's so high it can't come up with a value because we're not connected. We don't have continuity. We've got two probes in the air. But watch what happens when I touch the two. Our meter will now zero out or come real close to zeroing out. And what we're actually measuring here is the continuity through the leads. And as long as we get down near zero, it's telling me that the battery has got enough charge in it to give us a valid test. Other than that, this particular meter has got a selection scale, so we can get into different levels of resistance simply by hitting the select button and altering where we're going with it in terms of both the scale for ohms, whether we're testing a diode or continuity. So let's use the continuity scale. It's also got an audible signal. We're concerned with continuity here versus resistance. Okay, so it goes back to OL when I disconnect the two leads. I'm going to set the meter down for a minute, and I'm simply going to go from one end to the other, and I can hear the beep, which tells me I've got continuity. And I'm measuring a very, very small amount of electrical resistance. Okay? And that's fine. I expect to have some resistance in a coil of wire this long. Do I really care what the value is? Not particularly. I mean, I could find that out. Engineering texts and charts will tell you how many ohms of resistance you can expect per foot of wire. But I don't really care. I'm not worried about it. It's brand new cable. I've got continuity. We're basically going from one end to the other. I'd do the same thing if I were testing a diode. So that's our ohm scale. We just have to make sure that we don't touch the leads when we're on it, because it'll actually measure ohms of resistance and continuity through your body. Particularly if it's a hot day and you're sweaty and you've got sweat on your hands, that'll help to conduct. I'm not getting a reading right now through my body, which I'm dry and it's a breezy day and it's just not able to pick up a reading. So that's using the ohm scale and the continuity tester. This is the scale you would use if you were trying to make sure that you've got a continuous wire run through a long cable run. One last key point, you want the power to whatever cable or circuit you're testing turned off when you're using the ohm or continuity scale.